Let's get started. So let's talk about greatest common factor, least common multiple, and just a little practice. So let's warm yourself up. Let's get our brains thinking. Let's see what we come up with on these 5 problems. Go ahead and pause the video, and you can start again when you're done. All right. So let's looking at number 1. We've got greatest common factor. There are so many different ways to do this. You could create a list of factors where you'd write out, 1, 2, 3, 4, 6, 20, 12. And do it that way. Or you could do, and the factors are 31 and 30, 2 and 15, 3 and 10, and 5 and 6, and you'd find that 6 is the greatest common factor in both lists. You could say, and sit there and figure out if 30 is divisible by 12, then you go down the next factor and go to 12, 6 go into 30, and there's your answer. You could use the factor tree method, where you'd sit there and use your prime factorizations of each number and go, okay, 3, 4, 5, 6, 2, 3, and you look for the common numbers, a 2 and a 2. Hey, they both have 2's in common, they both have 3's in common. 3 times 2 is 6, it's the same answer. Or you're using that ladder method you learned when you were a little bit younger. And you said, oh, they both divide evenly by 2, so that's 6 and 15. And then they're both multiples of 3, so that's 2 and 5. And these are our greatest common factor right there. So we've got 6 for the first one. Our next one ended up being 18. If you've got 3 numbers, really the method I'd use is probably this one or a version of this where you kind of take the time and practice on it. Your lowest common multiple are the numbers that you get when you multiply the number times another number, not the parts of a number like a greatest common factor. So you go, easiest way on these is really to start with the smallest number. 8 times 1 is 8. 8 times 2 is 16. 12 doesn't go into 16. 8 times 3 is 24. 12 goes into 24. There's our answer. And doing the same thing here. This time, again, we're starting with our largest number. 12 times 1, no, 9 doesn't go into that. 12 times 2 is 24, 9 doesn't go into that. 12 times 3 is 36. Both of those go into it. It's the answer. Okay, you could use either one of those methods, but it makes more sense just to simply do the multiples in your head. And then we got to read on this one, on number 5. The key to this problem is this word right here. It's either word again, or the fact that we see how many times we flash again. Again means it's LCM. Because multiple means again, how many times they do it over and over again. So the lowest common multiple of 4 and 6, well, that's simply 12. Okay? So a little bit of warm up, a little bit of starting. Hopefully we're starting on the right track. So today we're talking about ratios, rates, and specifically unit rates and ratio tables. So let's get some vocabulary out of the way. The first thing we got to know is what a ratio is, and it's a comparison of 2 different quantities. Could be boys, girls, dogs, cats, teachers to students. There's a whole lot of different ways, and each one of those there's several different ways I could write a ratio. Whether I write it as a fraction, that's probably the most common. As I write it as a relationship in x colon y, this is probably the second most common, and this is probably the least common right here, where I use the word 2 instead of the colon. It really means the same thing. All 3 of those work, but by far fractions and the colon method are the most common versions of them. Then we've got 3 different things. So a rate is a version of a ratio. It's a ratio that looks with the different kinds of units. So where we have boys and girls, or paper clips, red and blue paper clips, or boys and girls, they're all the same unit. They're boys, they're just people or paper clips. That's where the ratio comes into play. But if I have rate could be something like dollars to item, to ounces, or miles to hours. All those are different units, so that's what I would call a rate versus a ratio. The biggest difference. A unit rate is our next piece, and this is probably the most useful thing we're going to get out of this class, is this idea is a unit rate. A unit rate is the rate for a 1 unit of a given quantity. So the key to that is really whatever it is over 1. Simplifying the ratio to over 1. Okay, and I mean, a ratio table is pretty simple. It's a columns filled with the pairs of numbers that all have the same rate or the same ratio. It could be either rate or ratio. Just depends on how you want to, which one it is. So these are the basic ideas. By far, unit rate's the most common idea that we're going to come up in place with. Okay. All right, last one is scaling. So scaling is a concept where you multiply or divide two related quantities by the same number. So you can think equivalent fractions and how you create two sets of equivalent fractions, that's scaling. Or reduce a fraction, that's scaling. Or, hey, I need to make, instead of 1 dozen cookies, I need to make 5 dozen cookies. I need to multiply each ingredient by 5 times so that I have enough to make the cookies. That's the idea of scaling. It's also, if you've ever seen a model, they're smaller than the real thing, so they scale them down. They divide them by the same ratios, by the same numbers, so that they stay the same basic shape. Okay? So when we talk about ratios, one of the ways we can talk about ratios is that relationship between two items. So in this case, it's between a ratio, see if our students have their favorite flavor of gum. Write a ratio that compares the number who choose fruit to the total number of students. So if we look at our chart here, we go, okay, 3 kids like fruit. And then it says the total number, so I've got to add all these up. So 9 plus 7 is 17, plus 3 is 9, plus is 20, 20 plus 1 is 21. That's my ratio. Now, because it can be written as a fraction, it all has to follow the fraction rules. If it can be simplified, it must be. So you'd say 1 in 7. So 1 in every 7 students should like fruit gum according to this survey. There are actually different kinds of ratios to look at. So we looked at one type where we have a part to whole, and that's a pretty common fraction relationship. That's how fractions are built. So fractions are truly really a ratio. But you can also have a part-to-part relationship, okay? Where you, instead of saying I have 3 kids out of everybody likes it, I could say 8 kids like cinnamon, 9 kids like peppermint. It's not a part to whole because that's not every student in the class. It's saying 8 kids prefer this, 9 kids prefer this. Two ideas. Just gives you a relationship between 2 different items, whether it could be pepperoni and cheese pizza. What's the ratio that helps you figure out, okay, I need more pepperoni, more cheese, depending on what your ratio looks like. Okay, you don't need to know the whole thing, you just need to see the relationships. Okay, then you've got another type problem. So I'm gonna let you guys give this one a try. Take a second and read this one and see if you can figure out the ratio of students that like fantasy books to the total number. All right, so if I read and I looked and I read and I found, okay, 5 students choose fantasy. So I've got 5, and let's see, 7 plus 9 is 16, 16 plus 4 is 20, 20 plus 5 is 25, so that's my total. Now that's still not right. 1 in every 5 students prefer a fantasy book over any other kind of genre. All right, so another way to look at it, and one of the things we've got to keep in mind as we go, as we talk about these problems, is when I'm doing the ratio in simplest form, I've got to be sure I'm writing the ratio in the correct order. And the order is given to you in the problem. So if we look at this one, it says baseballs to soccer balls. So you have to tell me that the ratio is 4 to 10, and then simplify it down to 2 over 5. If you don't have it in that order, it's considered wrong, because the reason it's first, the top number always becomes, or the first number if I write it this way, always is the first piece we're given. The second one is this, is the second number. So if you wrote 5 to 2, you give that answer wrong. It would be backwards. So just be sure as you read over ratio stuff that you're taking the time to read carefully, and so you get the correct relationship you're looking for. Go ahead and pause the video and see if you get the idea of ratio of red paper clips to blue paper clips. All right, so hopefully you saw that it started out with 2 over 8, but it ends up being 1 over, ratio red to blue isn't 2 over 8, it's 2 over 6, so the thing becomes 1/3. It's part to part versus part to whole. Okay. Now, let's keep looking. We can do the same thing with maybe a more up-to-date. Now, this is our first look at a unit rate. Remember, the key to a unit rate is it is over 1 of something, whether it's hours or minutes or dollars or pounds or ounces or gallons. It doesn't matter, but 1 of whatever the given quantity is. So typically, the idea behind it is the quantity is down here. The item is up here, okay? So if we're looking at this one, it says an adult's heartbeat is 2,100 times in 30 minutes. A baby's heartbeat is 2,600 beats in 20 minutes. Okay? How many beats would a baby's heart beat in 60 minutes how many more beats would a baby's heart beat than in 60 minutes than an adult heart? Use unit rate to solve. So the reason we have to use unit rate is we have to have what? Well, it's a fraction, so fractions have to have common denominators so that I can compare them. And by putting them over 1, whether it's an hour, a minute, whatever, it allows me to figure this out. Okay, so to do that, there's a couple ways I could take it down to 1 minute, or because this is 60 minutes, I could replace 60 minutes with 1 hour and use that as my idea. So that's the one I'm going to choose. So if I say my first ratio is 2100 to 30, I want to turn this into 60. Well, since it acts like a fraction, what I'm really doing is creating an equivalent ratio, which is the same as an equivalent fraction. So to turn 30 into 60, or in our case 1, we're going to simplify it out here all the way out to 1, I'd multiply this by 2. And since it's like a fraction, I treat it using the same idea of times 2. So this is going to be 4,200. And I could say, okay, that means there's 4,200 beats per hour, which there's my unit rate right there. And then I could also do the same thing with our 2,600 over 1 and go, okay, but this time this is over 20, not over 1. So this time, instead of multiplying it by 2, I'm going to multiply it by 3. So now I'm going to put that as 1 hour over here. 3 times 26 is 7,800. And now I'd simply subtract 7,800 minus 4,200. Hey, a baby's heart beats 3,600 times more per hour. Okay, go ahead and take the pause of the video and find out the same information about cats versus horses. All right, so let's go ahead and see how we did that. So you set it up as 3,600 over 30. This time we're going again to 60 minutes, so we can turn it right to an hour. We'll put 1 hour. That's 7,200. And then same thing, 1,320 over this time again 30. So we could actually have compared these and figured this out because they had common denominators. But we're going to move it up to unit rate. 2,640 over 1 hour. So we'd simply subtract 7,200 minus 2,640 and find out that a cat's heart beats 4,560 times more per minute per hour. All right, so that's kind of a little introduction to unit rate. Let's look at this idea. So here's that same ratio table we talked about. Sometimes we want to take a ratio and create several different ratios. So the first thing we'd have here is our cans, and we're going to have money, okay? It doesn't matter. We could put them either way. It doesn't really matter. Let's put $sign right here. So first thing we take is our information. We have 10 to 4. So one of the things we've got to do, it wants to know how to get to 15. And I can get to 15 by multiplying it by a fraction. But sometimes it's easy to go, wait, if I can go from 10, can I simplify this ratio to make it easier to get to 15? So I was like, well, if I simplify these, they're both even, so I can go down to 5 to 2. I scaled it. Can I get from 5 to 15 really easy without a fraction? Yeah, multiply by 3 times 3. So for 15 cans, it would cost me $6. So that's kind of one of the ways I could use a ratio table. Why don't you do the same thing to figure out what Eleanor needs to know about her yards of fabric to make 9 blouses, and then how many blouses she could make with 20 yards of fabric. All right, so the first thing we did is we created our ratio. Pardon me. Pardon me. So we have our blouses here and we have our yards here. So we get to this idea of, okay, so she can make 9 blouses with 12 yards. I know she has 20, but I can't really get from 12 to 20 really easily. But I could simplify. They're both multiples of 3, so I can get down to 3 for 4. And I go, oh, 4 to 20 is times 5, so she could make 15 blouses with 20 yards of fabric. Okay, and that works the same way whether John mows the lawns, okay, or we work our way up to Jeremy. So why don't you take a minute and solve both of these problems, John's and Jeremy's problem, and figure out how many lawns would he have to mow if he followed the same rate for 49 hours, and for this gentleman, how long, if he continues, how long will it take him to, how long will it take him to read 45 pages? And pause the video and figure it out. All right, so let's see how John does his stuff. So we're going to put lawns to hours here. So we know we start with our first one. He does 8 lawns in 14 hours. I need to get to 49. Okay, so I really can't jump from 14 to 49. It's not equal, but I can go and say, oh, these are both even again. Go to 4 to 7. And then I can go, oh, 7 times 7 is 49. So that makes an equivalent ratio, and I can do the same idea here. Oh, well, that's times 7, so is this. So he's done 28 lawns in 49 minutes. My next problem would work the same way. We're going to put pages here and minutes here. So we know that he's got 30 pages in 10 minutes. Again, I can't jump right to 45. There's no, I'd have to multiply by a decimal or a fraction, and why make my life harder? But I can go, oh, these are both divisible by 10. That would work. I can go down to a unit rate. I go 3 for every 1 minute. Well, all right, so if I divide both by 10, hey, that's great. So he reads 3 pages per minute. Man, this guy's a fast reader. So in 45 minutes, I go 3 times 45. That's 135 pages in 45 minutes. That's really fast. I could also have dropped it down to 5 and 15 and multiplied 5 times 9 and get 45, and 9 times 4, 15 and get 95. Or there's a myriad of ways I could do this. It doesn't really matter. I could have dropped it to 3 and gone, oh, okay, I can't divide it by 3. That's all the factors. I could divide by 2. I could go down to 5. I can divide by 5 and get to 2 and 6 and go from there. But that really wouldn't help me get to 45 because it's even. So I got lots of ways to look at that one. Now, Nico exchanged $50 American for $60 Canadian. If there's a ratio table to find out how many Canadian dollars he would receive for 20 US dollars. So American versus Canadian. So if he's 50 to 60, well, again, I can't really get straight from 50 to 20, so I can scale by dividing. Okay, well, they're both divisible by 10, so I go 5 to 6. So now I can go from 5 to 20 is times 4. Nico would have gotten $24 in Canadian money if he exchanged 15. All right, go ahead and take a pause and figure this one out for me. All right, so we've got cartons over minutes. So I'm going to set it up as 120 cartons over 70 minutes. And I want to get to 14 minutes, but I might not be able to jump right from 14 to 70. I mean, it doesn't work. I can't, it'd be 5. That wouldn't work. I can't, it doesn't divide evenly. Again, it's a fraction. So, but I can get to 14. So the greatest common factor of these two numbers is 7. So I can turn this into 7 and 12. And then I go, oh, times 2. They can pack 24 more cartons of books in that 14 minutes. Okay. So the last thing we're going to look at is deep into unit rate, just a little bit more. So we've got unit rate. Unit rate, again, is over 1. Find the unit price if it costs $2 for 8 juice boxes. So this is our quantity. This is our amount. So we're going to say 2 over 8. Now I got to simplify that. Go, okay, well, I've got to really, what I'm doing is I'm simplifying this to 1. So I would divide here by 8. If I divide 2 by 8, I get 25 cents per box. Then I do the same thing. Why don't you guys figure this out for our cans of soda? All right, so we have $3 per 6 cans. I'd simplify this down. Well, I go to 1/2, but I really need to divide here by 6. So I'm going to say, okay, that's 1. If I divide this by 6, that's 1/2 or 50 cents a can. All right, so that kind of gets you everything you need to know about unit rates and all that stuff. So good luck. If you have questions, please come see me. We're going to be happy to help you.